Alright, this is going to be the second attempt. I just want to start off with a quick showcase of a tool. So this is just to show that this is an empty level. This tool that I have here is called HISM Physics Baker Sim Toolkit. The point is for you to just add this to your project, and within this folder there's going to be a bunch of these files. Just go to simulators, additional, and this is all you need to drag in. To quickly show you what it does, you're gonna have to watch closely. There we go. So we did this tool because we wanted a way to naturally simulate bodies that had, undergone some physical movement and then save them. So it adds a lot of richness to a scene. So this is just a standard HISM. If you look here, this is just one actor. It's one HISM. So that's all the overhead you get. There's a bunch of things you can change with this. The first, most obvious one would be the mesh. And yes, that means it would respect the geometry of it. These are smaller meshes, so it's going to be a little bit tricky to see what's happening. But they bounce around like the cubes and they get saved. Another thing you might be wondering is, that simulation might have been a little too short. A lot of the bodies didn't get to settle, so you can increase that time. And there you can see the positions got saved. Funnily enough, the ones that fell off also got saved, so make of that what you will. But there's a bunch of other things you can change, of course. So the way this tool works, it randomly chooses a spot within your given area to spawn its physical actors. So I've added traces to give an idea. The circle is showing where the spawn point is. You can just make these quite small if you want a more deterministic solution. But you can see from the box traces just now that there's a bit more to it. So this is the area in which it's roughly allowed to spawn. And there's also height to the simulation. So if we pan back a little bit, you can see that. So if we did a much tighter simulation, let's say around here, what should happen is when I run this, they simulate much closer. And then of course they'll disappear for a little bit. And there you go. Again, there were all these actors that spawned initially, but if you click for it to refresh, you can see they're gone, because this is just one thing. It's one HISM actor. I think, okay, sure, that's cool. You can of course adjust the scale that is randomly given to these guys. You can adjust the number that you simulate. So let's try, I haven't tested this, but you can do that as well. What happened there was we simulated a lot of bodies in a compact area, so you get a bit of an explosion. So this has a runtime cost. It's a runtime blueprint, but it's also more importantly, it gives you a runtime cost at the start, and then all those actors that got spawned, they disappear, and you're just left with one thing that isn't nearly as costly. let's say you don't want that to happen. Let's say you want the bodies to have a little bit more breathing room. We're gonna have to test this. I don't have any numbers memorized for this. There was a little bit, but you can see all that information. It does affect the simulation, and you get it. You get this thing. I'll try one more time with, let's say, a slightly larger radius. Z radius, I just mean depth, so I think I'm okay with the height that we've been giving it. I just want to reduce the exploding effect, which you could use purposefully, but if you just want a relatively soft simulation, you could change around with the parameters and all that. So that's the simple version. Let's have a quick look at something like this. I just mocked up some demos. As you can see, again, this is an empty level. All this is done by simply dragging in your actor here. Let's change up the parameters since we kind of know to something a little bit more similar to what we had. I'm gonna go ahead and reduce this. This just adds randomness to the generation, the location of the generation. I'm gonna leave these here. We're gonna bump this up to our, let's say, 300. Our depth, we want this a bit more focused here, and let's see what happens. There we go. And again, you can see a whole bunch of actors here. If you refresh that, it's gone. One thing. Let's go to the next one. And again, this is an empty scene, and all you have to do is drag this guy in. Let's again use this guy. Let's say this time I made it less of a high thing. Let's start with 300. See what happens. It's got a little chaotic there, but you can see all of that information right there. So it does respect whatever the physics can respect. So it's I would say it's a whole lot better than what you typically can achieve with PCG, because stacking items is not quite something you can expect to have going for you. So I'm going to reduce the radius a bit, bump this up, see if I can avoid a little bit of that explosion just now. That works. Let's say we want more bodies. I hope this runs fine. Again, this still is bottlenecked by how many physics actors you can conceivably run, whether it's in your level or just in testing. So of course, practice caution. If not, you know, things go awry. There's that explosion effect you saw. But let's say we bump this up, make it a bit wider, and see if we can't fit 1,000 of these guys here, roughly. There we go. That's a lot better, I think. So we simulated it, it's done, and we get this pile. We get this pile that is one thing. I'm gonna save that. And I would also like to note that here's a pre-made example. I made one with the mesh that we've been using so far, but you can make for a bunch of meshes. Now these are HISM actors, so HISM is meant for simulating multiple meshes that have the same material. It helps you standardize your draw call. But if you want multiple shapes and you want them to interact, that's perfectly viable. And you just need an actor for each type of mesh. So let's try this. Alright. Now in this case it's not all one actor, right? It's three, but it's all HISM and they're just their own thing. You can almost get this silt, like if anyone's ever studied oceanography, the way sediments change, like sieve through depending on how big they are and all that. You get that sort of effect. I think that's pretty cool.